let's look at this question. So you can see that this is 20 e to the order of negative 500 t minus 10 ut minus 10. So there are both of them are t minus 10. So we can first set another function gt, which doesn't have this time shift, so it's just t ut. Okay, if we can find the Laplace transform of gt, we gave an example for gs, then we can just use the property, this property, time transfer property. So yeah, because this ft is just equals to gt minus a. Okay, t minus a, so it's a shift in time. So if that's the case, then Laplace transform of ft, which is capital Fs, just equals to something related to the gs, which is e to the order of as gs. Okay, first let's focus on this. How much is, what is the gs? Okay, then we're gonna use this equation, right? In this case, negative 500. In this case, a is positive 500. So capital GS equals to a 20 multiplied with 1 over s plus 500. Okay, that's GS. Then we know GT here, and the time shift in this one, this a is 10, right? We shift by 10. So the final result Fs equals to that 20 1 over s plus 500 multiplied by e to the order of negative 10s. Right? So that's the first question. Alright, so for part B, we need to extend this function. So this ft equals to, we're going to break this bracket, so it's 5t plus 20 multiplied with ut plus 4 minus 5t plus 20 multiplied with ut plus 2. Okay, so break this 2, and the next line I will write here. So this is a 5t ut plus 2. Okay, and minus a minus another. So this is a negative sign, this is a negative sign, so it becomes a positive sign. 5t ut minus 2. Okay, and the last term, we can keep right here. So last term, 5t minus 20 multiplied with a ut minus 2 minus a 5t minus 20 multiply with a ut minus 4. Okay. Alright, then we can start to collect terms. You can see here is a ut plus 2, here is another ut plus 2, and here is a ut minus 2, here another ut minus 2. So we can start to collect terms. So this 5 here, 5t here, we just leave it there, but we can take a 5 out, so it becomes t plus 4 ut plus 4. Okay, and minus, let's let's do a minus here, so both of them are minus, so we can make this u t plus 2, it's a common term, and the rest is a 5t plus another 5t, so it's 10t, and we can make this 10 out. Okay, make this 10 out, it's t plus 2. Okay, and for another one, and we're gonna plus a u t minus 2, and here is a 5t plus 5t, 10t. We take that t 10 out as t minus 2. Okay, the last one here is we minus a 5 out, t minus 4, u t minus 4. Okay, so you can see we're all in the form of like t plus 4, ut plus 4, minus t plus 2, and u, this is t plus 2 and ut plus 2, t minus 2, ut minus 2. So this all have the time shift. So if without any time shift, what does it look like? You can look here. It's just a t, right? It's just a t. So you can imagine that a 5t ut, if ask you to do a Laplace transform of that one, you will get a 5 multiplied 1 over s squared. Okay, but there is a time shift, so I bring this one here. We used this several times. Let's read. Okay, in the last question, so it does have a time shift. So if you include that time shift, this one becomes 5 multiplied 1 over s squared. That's from this one. After you do a time shift, you will have this one in there. And here, what you have shift, this is negative a, this is a positive 4. So in this case, a actually equals to a negative 4. Right? A is negative 4. So you actually multiply with e to the order of 4s. Okay, because a is negative 4. And then we minus this one. Minus this one, there's a 10, 1 over s squared. That's without time shift. Here is a equal to a negative 2. So we're going to multiply e to s. And we're going to plus a, this time a is a positive 2. This is a 10, 1 over s squared multiplied with e to a negative 2s, because a is positive number this time, and a minus a 5 1 over s squared, and this is the e to the order of negative 4s. Okay, if we collect terms, we can get something like this. We can get 5 is on top, and what being taken out is a e 4s minus a 2e 2s plus a 2e negative 2s minus a e4s, and in the bottom here is a s squared.